Alrighty, y'all, it's Mr. Montana here. We are going to go ahead and jump into our lesson 1.3, which is midpoint. And we are going to go ahead and start at the top section with this definition of a midpoint. So it is the point on a line segment that divides it into two equal parts. And it is the halfway point. And we use tick marks on this line. So if you look at these little red tick marks that I just highlighted in purple, those tick marks mean that those two segments are equal. So in other words, we can say that segment AB is equal to segment BC. All right, now moving on to question 1 down here. It says the endpoints of CD are -3 and 5. Use the midpoint M find the midpoint M of CD. So what we can do here, y'all, is we can go ahead and use our formula that is laid out for us here in this little handy dandy box. And it says to take the first point plus the second point and then divide it by 2. So right here we have point C. Over here we have point D. And then right smack dab in the middle, we have point M. And so now we need to be able to identify what point C is because it's not labeled. And so you'll have to look at your scale factor. So it's going to be 0, -1, -2, -3. So point C lies at -3. And you're going to do the same. So we're going to have 1, 2, 3, 4, 5. And so I know we can already see where point M is, but let's go ahead and do the math and double check that we were able to see the correct scale factor of our number line. So we are going to use the formula x1 plus x2 over 2, where x1 is represented by C and x2 is represented by D. So I'm going to have -3 plus 5 divided by 2. And -3 plus 5 is going to be a +2, and then over 2. And anything divided by itself, y'all, is going to be 1. So we know that the midpoint is at 1. And that would be our final answer for this question here. Moving on to question 2. What we are looking at is it says that point M is the midpoint of VW. Find the length of VM. And so this is going to take into our consideration our next formula, which is going to be part equals part. And I'll tell you, you'll get tired of all your teachers saying part equals part, but it is going to be essential for you to remember this. And so we can do part equals part because A, our pictures have these tick marks that I just colored in blue, which tells us that VM is equal to MW. So I always tell my kids to go ahead and write this out. So VM equals MW. That way you remember. And then VM is represented by the expression 4x minus 1. And then we're going to put our equal sign. And then MW is represented by 3x plus 3. All right, so now we're going to go ahead and want to solve for x by isolating for our variable. So we're going to draw our line. And then let's go ahead and move stuff around. So add 1 to both sides. Cancels that over there. Subtract 3x from this side. Do it to the other side. Cancels out there. 4x minus 3 is just x, or 1x. And then 3 plus 1 is going to be 4. So I have solved that x equals 4. And so now I need to look at my question. My question was asking for the length of VM. VM is again not represented by just an x. VM is the same thing as 4x minus 1. Well, now I know what x is, so I can go ahead and take this x and just substitute it in. So I would be left with an equation of 4 times 4 minus 1. And so 4 times 4 is going to be 16. And I'm going to take away 1. And so we will end up getting that this equals 15. So in other words, VM equals 15. And that would be my final answer. All right, this is what's going to really trick y'all. You want to stop right here when x equals 4. A lot of the times now, guys, we are not stopping when x equals 4. All right, we have to go ahead and plug back in and solve for something else. Looking at question 3, it says the endpoints of RS are R1, -3 and S, -5, 2. Find the coordinates of endpoint M. So, midpoint M, sorry, not endpoint. So, now what we're going to do, y'all, is we're going to go ahead and utilize this formula right here. I highly recommend that you label your coordinate points that are given with an x1, y1, x2, y2. That way when you're plugging into the formula, it just makes it a little bit easier. And so let's go ahead and plug in. My formula says x1, which we have represented by a 1, plus x2, which is a -5/2, comma, y1, which is a -3, plus y2, which is a 2, all over 2. And so now 1 plus -5 is going to be -4/2, comma, -3 plus 2 is going to be a -1/2. And now we have to simplify. Does -4/2 simplify? The answer is yes, and it goes down to a -2. Does -1/2 simplify? No, it doesn't. It just stays -1/2. So my midpoint would be at -2, -1/2. All right, now looking at question 4, it is talking about the midpoint of JK is M, which is at 2, 1. One endpoint J is at 1, 4. Find the coordinates of endpoint K. So this right here, it's very crucial that you are going to be able to draw a diagram. So we are given the line segment name, and it tells us that my line segment is going to be called JK, and it's going to have a midpoint of M, which tells me that this point side is equal to this point. And then it goes to tell me that point M is at 2, 1, and point J is at 1, 4. So now what you need to understand is that the difference between my x values is going to be the same from one endpoint to the midpoint, from the next midpoint to from the midpoint to the next endpoint. So in other words, from 1 to 2 is going to be the same difference from 2 to whatever this new point is going to be for point K. So what did I do to 1 to get to 2? So I ended up adding 1. And so the same method is going to follow here. So I should add 1. So 2 plus 1 is 3. And now I want to go ahead and take a look at my y values. So from 4 to 1, to get from 4 to a 1, I had to subtract 3. And it should hold that it's the same process to get from M to K, because those segments are equal. So what is 1 minus 3? It is going to be -2. So point K should sit at 3, -2. And let's go ahead and plot these points. That way we can make sure that it looks right. So it said that J is at 1, 4. So right 1, up 4. We have point J. M is at 2, 1. So 2, 1. And then K is at 3, -2, which is going to be here. And if I connect these dots, we should have something like that. And these do look like they are equal segments, so we did it right. Now moving to the back page. When looking at the definition of a segment bisector, the definition is a point, ray, line segment, or plane that intersects a segment at its midpoint. Alright, and so what that means, y'all, is if we have a segment bisector, it creates two equal line segments. So taking a look at question 6, alright, we have one big segment, which is AB, which is highlighted in purple here. And then we have ray MC, which is highlighted in pink, which is now bisected, which we're going to go ahead and say bisected means cut in half. All right. Segment AB. Therefore, what we should be able to understand is that from A to M is going to be equal to M to B because those segments are equal. So let us go ahead and solve for what segment MB is equal to here. It tells us that AM is 5, but we also know that that is equal to segment MB. That is represented by an X, so X equals 5. Therefore, y'all, we go a roundabout way of saying that the measurement of segment MB is also 5. All right, now looking at question, what is said to be 5, it should be 7. We have a line that is cutting across a segment. So my line is QP that I've colored in green, and my segment is AB that is now colored in blue. So again, we are saying that this is bisecting, all right? Saying that it is bisecting. So that means that segment AC is congruent to segment CB. All right. So with that being said, I can plug in what represents AC, which is 9x plus 18, and set that equal to what represents CB, which is 12x minus 21. And then we're going to go ahead and solve this. And so what we are going to do is we are going to subtract 9x, subtract 9x, draw my line down the middle, add 21, cancels out there, cancels out here. 18 plus 21 is going to be 39. And 12 minus 9 is going to be 3. And the x stays. Last step, divide by 3. And you get that x is going to equal 13. All right. And then if we look at these questions down here, we'll go back to question 6 here in a minute and solve it. It says, what is the segment bisector? All right, my segment is AB because it has 2 endpoints. Now it wants to know what is bisecting it. So what is cutting it? And so we already talked about it, that it is line QP. Line QP. And then the next question says, what's the length of AC? And so, y'all, AC is represented by 9x plus 18. I now know what x equals, so I can go ahead and plug in. So I get 9 times 13 plus 18. 9 times 13 is 117 plus 18. So I get that AC is going to equal 135. So I go ahead and write that on that blank. Hopping back over to question 6 really quick. The segment bisector, we already talked about that, is ray MC. And then now it says what's the length of AB. So we didn't solve for what AB was. We found MB, which we said was 5. And we know AM is 5. So we know that AB is going to be equal to AM plus MB. So in other words, we are just doing 5 plus 5 equals AB. Therefore, AB is going to equal 10. All right, moving on to the next question, question 8. Question 8, marked as question 7. All right, question 8. It says find x on AF that is 1/6 of the distance from A to F. All right, so guys, this is called partitioning. I personally do not use these steps over here. I will give you an easier way to remember it. So how I remind my kids to do partitioning is to always do the big number minus the small number. Now we're going to multiply by fraction. And then 3, we are going to add to small number. All right. If you choose to use those steps in the box, that is perfectly fine. But for the purposes of this video, we are going to go ahead and continue doing my steps that I wrote in purple. So we are talking about segment AF in this question. So from A, pick a different color, A all the way to F, which is right here. So the easiest way to understand this, y'all, is my big number is going to be 5 because 5 is bigger than -7. So I'm going to do 5 minus -7. And when we see a minus a negative, we have to remember to chop, and they both come positive. So 5 plus 7 is going to be 12. And then it says to multiply by the fraction. So in my question, the fraction is 1/6. So I'm going to do 12 times 1/6. And you can type this into your calculator, or you can put this 12 over a 1 and you multiply straight across. So I'd get 12 over 6, which we should all know is actually just 2. And then for step 3, it says to add it to the small number. So I am doing 2 plus -7. And so 2 plus -7 is going to equal -5. And so I would be able to say that x on this number line is at -5. Now moving on to question 8. It's the last question of the worksheet, and it is a partitioning question. It says find the coordinates of point P on CF if the partitions of the segment are a ratio 2:1. So we are looking at C to F, which is that segment right there. And now we need to understand how to change this ratio to a fraction. So ratio to fraction, the easiest way to remember this, y'all, is to do add numbers and then first on top, sum on bottom. So in other words, I'm going to do 2 plus 1 equals 3. The first number in the ratio is 2 over the sum, which is 3. And so now that is my fraction that I will be utilizing for my partitioning. And so guys, there's another easier way to do this partitioning if you're given a number line. You can just simply also count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know that my distance is 9, and I'm going to multiply by 2 over 3. Same thing, set that 9 over 1 and equal 18 over 3, which is going to simplify to 6. And then we add it to our small numbers. So 6 plus negative 4 is going to equal 2. And just so you understand where this 9 came from, y'all, I'll do the quick little process. It would be 5 minus negative 4, chop, chop, equals 9. And that's where that 9 came from. Alrighty, y'all. That's all I have for you today. I hope you enjoyed, and have a good day.